Today we're going to talk about how to convert from rectangular to polar coordinates. So here I have 2, -2, and what I did first was draw which quadrant my point is in, so it's in quadrant 4 here. And then your first step is to find the radius. To do that, I have r equals the square root of x squared and y squared, and that just comes from the Pythagorean theorem. So what I'm going to do is plug in the x and the y, so that I get r equals 2 squared plus -2 squared. After you plug all that into your calculator, you get 2.83 for the radius. Now I have to find the angle, because the polar coordinate always has a radius and an angle. So to get my angle, I use tangent of theta equals y over x. Now the reason it equals y over x is because y is sine and x is cosine, and we know tangent is equal to sine over cosine. So now I plug in my y over x, so I get -2 over 2, and that gives me -1. So now what I have to do is go to my unit circle and find where the tangent of theta is -1. But I have to find that in quadrant 4 here. Since our rectangular coordinate was in quadrant 4, I have to find where the angle is in quadrant 4 as well, and the tangent's -1. So if we go to our unit circle here, tangent is -1 at 7 pi over 4 and 3 pi over 4. 3 pi, 7 pi. But since we want to be in quadrant 4, then I need to be in this part, so that's going to be 7 pi over 4. Or I could write that as a negative angle as -pi over 4, because that's also -pi over 4. So that's why theta is 7 pi over 4 or -pi over 4. And so then my point here, I just write the radius and the angle. So 2.83, and again 7 pi over 4, or I can use -pi over 4. We'll do one more. We have 5, -8. 5, -8 is in quadrant 4 again. We've got to find the radius by taking the square root of x squared plus y squared. That's 5 squared plus -8 squared, and when you plug that in your calculator, you get 9.43. 9.43. So that's my radius, and now I have to find my angle. So tangent of theta, remember, is y over x. I'm plugging my y and my x, so I get -8 over 5. Now we know -8 over 5 does not lie on the unit circle. It's not a defined point on there that we can pick from. So what I have to do is use my calculator. And since we always want theta in radians, you need to make sure you're in radian mode. So I hit my mode, and I am in radian mode right here. So now to find the tangent, I'm going to take second tangent of -8 over 5, and that gives me -1.01. So that's why theta is -1.01. Now, what I've written on the side over here are some notes. If we are in quadrant 1, then we're going to keep whatever the calculator value tells me. If our point should be in quadrant 2 or 3, we're going to add 180, which is pi. That's also pi radians. And if it's in quadrant 4, we need to add 360, or 2 pi radians. So here, since we are in quadrant 4, what I need to do is take this number and add 2 pi to it, and when I do that, I get 5.27. So my angle is actually 5.27 radians. So then my point P is going to be at 9.43 and 5.27 radians. Now again, these rules only apply when I have to use the calculator. But like that first example, since we use our unit circle and we went straight to the quadrant we were in, we didn't have to use these rules. This is only applicable when we use the calculator. And that's how you convert from rectangular to polar.